In the following example, we're going to be taking a look at series, but let's first look at a couple of definitions. The first thing we're going to talk about is a sequence, and you're probably familiar with the sequence. It's a collection of objects. Order matters. Could be a collection of numbers like 1, 2, 3, 4, 5. Could be the set of maybe even numbers 2, 4, 6, 8, 10. Could be a set of odd numbers, right? But we're going to be talking about what's called an infinite series, all right? So what exactly is a series? Well, it's the sum of an infinite sequence of numbers. So if you have an infinite amount of numbers and you wanted to just add them all up, well, what would it equal? So what we do is we're finding something called the partial sum. And there's actually a formula to generate the partial sum. And then what we can do to find the sum is take the limit, okay? So there's a formula, if you will, that will generate the sum, all right? But there's a couple of things that you can do, okay? So what we're going to do is first figure out, well, what is this formula? All right, so let's write out the formula. So to find the formula for the nth partial sum, we have to look at some components of what we're looking at here, which is a geometric series. First thing we have to note is that there's this initial component a, the initial value a in this case. So the 2 here represents our a value. And then there's something called the common ratio, and that is what is the number that each element gets multiplied by as you continue to add on to the series here, or add on to the sequence, I should say. And so if we look here, we have 2 followed by 2/5 followed by 2/25. So what seems to be going on here is that we're multiplying by 1/5 in each successive step. So our common ratio r equals 1/5. Okay. Now what we'll find out later on in this section of study is that in a geometric series, if your ratio is less than 1, then the series converges. Okay? If it's greater than or equal to 1, then we say the series diverges. So in this case, this r equals 1/5 tells me this converges right away. All right? So let's go ahead and try to make some sense of it by first seeing how we can generate the formula. So the formula, if you will, for S sub n, for S sub n equals, it looks like this, it's a, that initial value, times 1 minus r to the nth power divided by 1 minus r. So I can set this up. All right, I can set this up to find S sub n, my formula. My a value is 2, so 2 times 1 minus r, which is 1 over 5, okay, to the nth power, all right, divided by 1 minus r, which is 1/5. Okay, so let's see what that kind of looks like here. This ends up being 2 times 1 minus 1/5 to the nth power divided by 1 minus 1/5 is 4 out of 5. Okay, and what we're going to do here is we're going to take the limit. Okay, we're going to take the limit as n approaches infinity of that series S sub n, of that formula rather. So let's take a look. The limit as n goes to infinity of 2 times 1 minus 1 over 5 to the nth power divided by 4 out of 5. Well, 1/5 to an infinite power, all right, it's going to get smaller and smaller and smaller as you go to infinity. So that being said, this part right here is going to go to 0. And you're basically left with 2 divided by 4/5, which when dividing fractions, I always tell my students to remember to KFC, that is, keep the first fraction and flip the second fraction. So 4 over 5 becomes 5 over 4. And then we multiply and simplify. 2 times 5 is 10 out of 4, which reduces to 5 out of 2. So the partial sum of this convergent series is 5 over 2. And then the formula, if you will, this right here is representative of the formula. Okay, so let's go ahead and take a look at another example. And we're going to see here on this one that I'm going to call number 2. I have 7 minus 7/4 plus 7/16 minus 7/64, and so forth and so on. All right, it's going to end up being something that looks like this: -1 to the n minus 1 times 7 over 4 to the n minus 1. So this is a fancy way of telling us what's going on here. But all we have to do is pluck out the a and the r. Okay, but kind of notice here that this alternates in terms of sign: positive, negative, positive, negative, positive, negative, right? So you should take that into consideration as you're trying to identify your a and your r. Our a in this example, the first element is 7. Our r looks like it's 1/4 because that seems to be the common difference here: 1/4, 1/4, right? But it alternates based on its index, whether it's the first element, the second element, and so forth, right? So it's actually going to be a -1 out of 4. Okay, -1 out of 4 that represents our r value. But otherwise, the formula is the same as before. So S sub n will equal a, which is 7, times 1 minus, and then it's a -1/4 to the nth power, all divided by 1 minus a -1/4. Okay, so we can simplify just a little bit. 7 times 1 minus, and then it's still -1/4 to the nth, divided by 1 plus 1/4, which is 4 out of 4 plus 1 out of 4, 5 out of 4. And this right here is the formula, if you will, because we're asked to find the formula. All right, and then now that we've got that, okay, what we'll do is we'll find the limit of S sub n, and it's the limit as n goes to infinity, okay, of S sub n. It is the limit as n goes to infinity, then of 7 times 1 minus a -1/4 to the nth power, divided by 5/4. So this -1/4 to the nth goes to 0 as n goes to infinity. This leaves us with what? 7 divided by 5/4, which is the same as 7 times 4 out of 5, which is what? 28 out of 5. So this right here, this series sum converges to 28 out of 5. Okay, and it's just as simple as that. So, as always, I hope this video was helpful. And remember, like and subscribe.